Hey everyone, welcome to the 4.8 notes. So we're going to be talking about conjugate roots. A conjugate is something like this, where you would have x plus 2 and x minus 2. These are conjugates because you pretty much have the same expression, but the sign in between them is the opposite. And the most important thing to know about them is when we multiply them together, or the unfactored version would be this. Because this is called difference of squares, you would get your x squared here, but then you would get negative 2x and 2x, which add to 0. And then you would have this negative 4 left at the end. So the ones in the middle add to 0. So you're going to see a lot of 0 placeholders in the middle of these problems. Okay? And the rules that we're going to talk about with them are irrational, which means square root ones, and complex, which means that they are going to have an I. And the same rule applies to both of them, and that is that if you have a answer of a plus the square root of b, I'm just going to call this square root of 7 as an example. Then a minus the square root of b, so the conjugate has to go with it if they're irrational. So these don't have to go together because they're not square roots, but if you do have a square root, basically all this is saying is the negative square root has to go with it, because the only way to have gotten these would be if you were to have taken the square root on both sides, and we all know that when we do that, or should know that when we do that, we get a plus and a minus. The same thing happens when you get an I. And I'm going to come over here and write the example that would have given us this answer. So when you do the square root on both sides to get the square root of 7, you need to add a negative 1 as well. What this is saying is that square root zeros can only come in pairs. Same thing goes for i's. The only difference would be we would have something like, say, x squared equals negative 9. And then we would do the square root on both sides. And because we're doing the square root of a negative, our answer wouldn't just be 3, but it'd be 3i and negative 3i. So for square roots and i's, these can only come in pairs. So it's impossible to have an odd number of them, because if you have one, you have to have the negative one with it. Okay? And then don't forget the fundamental theorem of algebra that says that if your degree is n, then it has n zeros. So if it has a degree of 4, then it has 4 zeros. If it has a degree of 3, then it has 3 zeros. Let's put this into action, and I think it'll make a little bit more sense. So x cubed minus 3x squared plus 25x minus 75. We are given that 3 is a root. So what we're going to do is put the 3 up here in the corner. And this is like the backside of 4.7, where if you know what the number is, synthetically divide by it. So then I put my coefficients over here, and I'm going to divide. Remember that the whole reason why we're dividing, or synthetically dividing, is so that this will turn into an x squared, and we can either factor it or solve it another way. The first thing you're going to do is put this one down here. Then you're going to multiply. 3 times 1 is 3. And add down. Negative 3 plus 3 is 0. 3 times 0 is 0. 25 plus 0 is 25. And I made a slight mistake that I'm realizing now, because 3 times 25 is 75. And this is supposed to add to 0, but it doesn't right now, because I forgot the negative on this 75 up here. So that was supposed to be a negative 75. And that means it actually does add to 0. So if you're not getting this last part to line up like it's supposed to, go double check your math. I happen to have missed a negative. There we go. Then we're going to take this and make it back into our answer. So this is our constant, this is our x, this is our x squared. So I basically have x squared plus 25. And we're going to want to set this equal to 0. Now, I can't factor this because there's nothing that multiplies to 25 and adds to 0 in the middle. So what I'm going to do instead is solve it with the square root. I'm going to minus this 25 to the other side first, and that leaves me with x squared equals negative 25. Then I need to take the square root on both sides, because the way to get rid of a power of 2 is to take the square root. And when I come over here to take the square root of negative 25, that's going to leave me with plus and minus, because I did a square root. And then because of this negative, you can't take the square root of a negative unless you add an I to your answer. So this is going to be an imaginary answer. And then the square root of 25 is 5. And this is why they can only come in pairs. So I basically have 5i, negative 5i, and that's 2 zeros. I should have 3 because it was a power of 3. And that is because I need to include this 3 that it already told me was a root. So don't forget the one that you start with. Always make sure that the number of zeros matches the power, the highest power. Okay, let's do one more. This one says x equals 4 is a root. So I'm going to put 4 over here, and then I'm going to fill in my coefficients. And I'm not going to miss any negatives this time. 1, negative 7, 6, 42, negative 72. And before you freak out that some of these numbers are a little bit higher, we're only going to take it one step at a time, so it really won't be so bad. Drop the 1 down, and remember that you are multiplying these two, that's 4, and adding these two to get a new number, negative 3, that gets multiplied by the 4. Negative 3 times 4 is negative 12. 6 minus 12 is negative 6. Negative 6 times 4 is negative 24. 42 minus 24 is 18. And 18 times 4, you can kind of guess, 72. Make sure that 18 times 4 actually is 72, and you're not just kind of like making these up so that they match correctly. Okay, now we have a few extra numbers on this one. This is going to be my constant. This is going to be my x squared, and then I actually get to go all the way to x cubed on this one. So I have x to the third minus 3x squared minus 6x plus 18. And what we're going to do is factor this. Since there are 1, 2, 3, 4 things, that's where you're going to group these two and these two together. Over here, we can divide those both by x squared. And that leaves us with x minus 3. And on the right side, we can divide those both by 6. And we don't want the first thing in the parentheses to be negative, so we're going to divide them both by negative 6. And that leaves me with x. 18 divided by negative 6 is negative 3. Look at that, x minus 3 in both. Remember that this is the part where you write the one that matches out front, and in the other parentheses you put whatever was on the outside. Okay, and then we're going to find our zeros. So we need to set both of these equal to 0. I am not going to write down one step, but I will say it out loud. I'm going to add this 3 to the other side, and that's just going to be x equals 3. I'm going to add the 6 to this side, and that's going to be x squared equals 6. Because it's x squared, I do still need to do that square root on both sides. And there is no square root of 6, so this is just going to be plus and minus the square root of 6. Okay, so I've got 1, 2, 3 zeros. Don't forget about the one we used up here. So now I have 4 to match my x to the 4th power. And that's it. That's why they have to come in pairs. So it is impossible to have an x cubed one like this that only has i's, because if this one was imaginary, then we would have to have another one with it. So you can't have an odd number of imaginary roots. You also can't have an odd number of square root roots. It is possible that all of these could be square roots because there's 4 of them, so they could all kind of match together. There are going to be some true and false questions on the homework about that. All right, over here on the right, we are given -2 is our root. So put that in the box, and I'm going to go through this one a little bit faster. 1, -1, -2, -4, -24. Make sure you get all your numbers. Don't miss a negative like me. Drop this one down. 1 times -2 is -2. -1 plus -2 is -3. -3 times -2 is 6. -2 plus 6 is 4. 4 times -2 is -8. -4 plus -8 is -12. And -12 times -2 is 24. And then we're going to make this into our equation, or our polynomial, constant x, x squared, x cubed. So I have x cubed minus 3x squared plus 4x minus 12. And I'm going to group these two together. I can take out an x squared or divide by an x squared, and that leaves me with x minus 3. Kind of like this one. Notice how they start the same way. But the next part is a little different, because on this one, I just need to take out a 4. Since this 4 is positive, I don't need to make this negative the way I did with the 6 on the left. 4x divided by 4 is x. -12 divided by 4 is -3. So I have my x minus 3 that matches. And from the outsides, I get x squared plus 4. And then I'm going to set both of these equal to 0. Over here, I'm just going to get x equals 3. Again, this one was already on the other side. And over here, I'm going to subtract that 4. So x squared equals -4. And I'm going to do the square root. But when I do the square root of -4, I need an I. The square root of 4 happens to be 2. I just need to put an I with it. And don't forget that every time you do that, you also need -2i. And those are 3 of your zeros. The 4th one is right here. So -2. Always make sure you have 4 zeros if it was an x to the 4th problem. And lastly, down here at the bottom, we're going to write an equation. Whenever you're writing the equation of a polynomial, you're going to start with the factors like this. So if there is a 0 at 3, that means that this would have been x minus 3. Okay. Another way of thinking of that is if you said x equals 3 and you wanted this to turn into 0 because it's the zeros, that's what ends up going right there. Okay, but that's kind of confusing. It's always just the opposite. And then what we're going to do over here is, since this was 3, it was x minus 3. So since this is 4 minus 3i, it's going to be x minus 4 minus 3i. And notice how I wrote that above for a second. I'm going to put it in the parentheses on the same level in just a second. But I really don't want to do this double parentheses thing. So what I'm going to do is take this negative and multiply it. That's going to make the 4 -4 and the 3i positive 3i. Then don't forget, this is cubic because there should be 3 sets of parentheses. The last one is going to be x minus 4 plus 3i, or x minus 4 minus 3i. So you're going to distribute that negative. What you'll notice is that this ends up being x minus this number and x minus that number, same thing. And then the 3i is going to be plus in one of them, minus in the other one. Because it doesn't matter what order they go in, it doesn't really matter if you write this part down first. Sorry, didn't mean to cross through that. And that's your answer. Okay, just since you're writing an equation in front, we should put an f of x equals. And then coming over here, a fourth degree polynomial with a 0 at 2. So that's going to be x minus 2. And negative square root of 3. So that's going to be x minus negative square root of 3, which becomes x plus the square root of 3. Or you can think of this as just the opposite. And if there's one at negative square root of 3, that means that there's also one at the square root of 3. So you'll also have one that's x minus the square root of 3. And then count them up, there's 1, 2, 3. So we need a fourth one somewhere. You can add a fourth one however you want. Here are some options. You could make this one a double root. You can't make one of these a double root without making the other one a double root. So since we only need one more, you can't do that. You could also just make up your own. You could add an x outside if you wanted to. Or let's say your favorite number is 10. That's my favorite number. I could add an x minus 10 out here. I can really add whatever I want as the last one, as long as I am making sure that my degree is 4. Okay, so these parts, I guess I should have circled that. This is just me making sure that I'm adding a fourth root or 0 or solution.